Now let us imagine that we are engineer A and the team leader has just assigned us a task. So let me open the file that he has given to me. So I can go for open. Here I can go for engineer A and here I will open this file. Once you open the geometry, properly observe the geometry. So if I go for component, I have two components, left rail inner and outer. Next thing that I will go for is the geometry cleanup. So let me go for by 2D topology. Here you can observe the geometry properly for any free edges or duplicate surfaces. Now to check the duplicate surfaces, we can go for geometry, defeature, let's say duplicate, select all the surfaces and say find. As you can see, he has found one duplicate surface and let me just delete it and let's say return. Now again zoom in and properly observe the geometry. We can observe at this location we have a free edge, but here since it is not our boundary edge, here it should not have the free edge. Moreover, if I go for boundary, then you can see here I have the shared edge. That means at this location there might be possibility of overlapping surfaces. So let me go for quick edit. Here I will go for delete surface and I will simply delete the surface. As you can see, now that free edge has been removed. Now as a last check, I can go for isometric view. Then I will go for visualization. I will suppress the shared edge and the suppress edge. So I will remove this tick and this tick. As you can see here, I can only see the free edge and non-manifold edge. So let me go for wireframe mode and now free edge should be at the boundary or at the cutout sections. So let me zoom in. I will switch off the display of points and observe the geometry properly. As we have observed, we didn't find any free edge in middle of the section. So from now on we are ready for meshing. So let me close this one. Let me close this one also. Let me go for visualization. I will switch on shade and suppress edge and here I will switch on the surface. And let me go for model browser. Let's first mesh the left rail outer. So I will isolate it only. And we will use all the rules that we have studied so far. Now before starting the meshing, I will go for parameter file and I will import that file. So I will go for preference. I will go for criteria settings. I will go for open. And from here I can say left rail engineer A quality file and I will just say open. Now the quality has been loaded. So we have to mesh the component with size of 10 and follow these parameters. So let's say OK. Now I will go for meshing. Since we have already seen all the rules related to meshing, from now on at important point only I will tell you. Rest of the point you can just observe it and you can follow it. We have to remove this triangle, but since with the help of local remeshing it is not getting removed, with the help of quality index I am going to remove it. Here you can either drag the try element like this, or better option is to go for swap edges. So let me go for swap edge, select the edge. See, this is how it has been swapped. Now I can go for drag try element. Let's move it out of the boundary and from here just throw it out of it. Here I have shifted this triangle from this location to this because I cannot simply throw this triangle from this location since we have the fillet to follow over here. As you can see, all the triangles have been removed. I can go for smooth operation. While performing the smooth, you can observe in the status bar the displacement of final iteration. So once displacement becomes less than 0.01, you can stop the smooth operation. As you can see, the flow of mesh is very proper. So at last I will go for quality check. So here I will shift element visualization to by element quality. And as you can see, only one element is failing. So let me observe that element. And here the element is failing in minimum size, as you can see over here. To remove this quality, again I will go for quality index, say place node. Now once the meshing is complete, let me go for quality checks. As you can see, we have completed our meshing and all the elements are satisfying our quality criteria. Now the last thing that you have to do is check the mesh flow lines. So I will hide the surface and I will go for mesh line. Here all the elements looks good. Now next thing that I will do is to check for equivalence. So I will go for Shift F3. Let me select the displayed nodes and let's say preview equivalence. Now since we haven't performed any operation like reflect, rotate, spin, that's why it was not necessary to check it, but to be extra cautious, it is always good practice to check whether there is a proper connectivity or not. Next we will go for meshing of left rail inner component. So let me isolate that component only. As you can see, washer have already been placed by the client himself. That means even if the element fails in the washer region, that is acceptable because this is how he wanted the washer. So again I will go for zoom in. Let me first mesh the washer area. As you can see, elements are not getting placed in the left rail inner. So I will go for Ctrl Z and here instead of current component, I will set it to surface component. And again I will mesh it. On this fillet we have to check whether we will be able to fit two element or not. So I will go for surface, mesh it, let's set it to 2 and immediately I will measure the length. So I will go for F4, let's say 2 nodes, and select the 2 nodes. Since our minimum element length criteria is 5 mm, here it is not possible to place 2 elements. Even if I go for by element quality, here you can see these elements are failing in minimum size. In such cases, you can do two things. First, you will call the team leader and you will ask which one is important, whether it is important to place the 2 element on fillet or it is important to follow the element quality. So if he says that it is important to follow the element quality, then on the fillet we are going to put only one element. But if he says that we are going to perform the structural analysis and it is important to have the minimum 2 elements on the fillet, then we are going to follow this criteria. So in particularly our case, we are going to focus on following the element quality. So that's why I'm not going to put the 2 layer of element over here. So again I will go for F12, mesh it with only one element. Here also I will have to do the same thing. You can see here also it is failing in minimum element length. So again I am going to put only one element over here. After putting the one element, you might see there is a deviation of an element from the surface. Well, it is acceptable. This is again a critical region where we have to decide what should we do, whether we are going to put 2 elements or we are going to follow the element quality. Now in this particular case, since the fillet is little bit larger, I can do one trick. I can go for Shift F4, that is translate. I will select the node by path. And here I will translate this node along this direction, and I will say the distance to be transferred is 0.5, and let's say translate plus. Again here I will put 0.6, or let me say 0.2, a smaller distance. As you can see, the quality has been removed. Now same thing I will try to do it over here. Again, let me clarify, this is an exclusive case in which you can do such things. But first confirm with your team leader that whether you are allowed to do it, because by doing so we are basically increasing the fillet radius. Let me go for return. As you can see, at this location now the quality has been destroyed. So again I will have to repair this quality. As you can see on the other side, we have created two layers of chord elements. Now here also we have to do the same thing, because in meshing there is a rule called as an same feature same mesh. That means at particular location you have applied some strategy, then same strategy you have to apply throughout that location. This deviation of an element from the geometry is allowed because we have to maintain the quality. As you can see, I have total 86 number of elements that have been filled, but most of the elements are lying on this fillet. So one thing that I can do is translate this element in either upper or in the lower direction. So if I go for nodes and if I measure the distance is 4.9. That means I have to translate them by the amount of 0.08, then this quality will get removed. As you can see, only 32 elements are failing. That also are failing only in the washer area. But since the client has given the washer, I will keep this element as it is. And now I will go for smooth operation. From smooth, I will remove the washer area because I don't want to change the mesh in that region. And now we can focus on removing the triangular element. Here, to place this node on this line, I can go for project. I will select this node, then select the line and just say project. Next, you can try to remove this triangular element by the methods that we have seen. For example, this triangle and this triangle, they can be eliminated with each other. We can do the split edge for this triangle. For example, we can go for quality index, say swap edge, select this edge, select this edge, and then just say split or collapse edge. You can see a triangle is no longer touching washer. So by this method, you have to remove the as many as possible triangular elements, and then we are good to go. So in this way, basically, engineer A has performed all the meshings, and only here we have to do the smooth operation. Let me do the smooth over here. And now he can give the geometry to his team leader, where team leader will again check the elements quality and the mesh flow. For example, you can observe over here on the right side, if I measure the distance, let's say 2 node, here I have the total distance of 36. Let me measure the distance over here, and here also I have the 36 element. But if I carefully observe, here I have 1, 2, 3, 4 and 5 layer of chord elements. But on the other side, if I check over here, I have 1, 2, 3 and 4. That means only 4 layer of element. So engineer has to be very careful to get the proper mesh flow lines. For example, here I can go for quality index, I can go for drag tri element, and here I can drag this triangular element. Then again I will go for smooth operation. Let's say element, and let's say smooth. As you can see, now I have 1, 2, 3, 4, 5. So in this way, if I remove this triangular element, I will get the proper flow of mesh lines as we have on the other side. Now because of time limitations, I am not able to do it over here, but in your project kindly do these things. I have put the reference file for this component. In that component you can observe how the flow is going. Now let us save this file, so I can go for file, save as. Here engineer A, I will remove his name now, and instead of it I will say final. Generally instead of final, some company would like to put the delivery date. For example, if I am delivering the project today, I will put the today's date. But for time being we are going to keep this as a final only.